In this video, I'm going to discuss negative exponents and what we need to do in order to deal with them. So we have a little definition here that I've got typed out. If x is not 0, so any non-zero number, and n is going to be an integer, and integers are like -3, -2, -1, 0, 1, 2, 3, then we've got a couple of equations here. We've got x to the power of negative n, we can rewrite as 1 over x to the positive n. So essentially what we've done, it looks like we've taken the reciprocal of this x business. Instead of x, it's 1 over x. And in doing that, we can change this negative exponent to a positive exponent. Likewise, if we have 1 over x to the power of a negative n, we can rewrite that, again, kind of taking the reciprocal. So instead of 1 over x, we just have x. And then in doing so, our negative exponent changes to a positive exponent. So let's look at an example of what that might look like. If we have 2 to the power of -3, I can rewrite that as 1 over 2, and once I've taken the reciprocal, this -3 changes to a positive 3. So it's 1 over 2 to the positive 3, which we can also say here is 1 over 2 times 2 times 2, and this 2 times 2 is 4, times 2 is 8. So my answer here is going to be 1/8. So 2 to the power of -3 is 1/8. So let's continue and look at another example here. I'll kind of shift down our definition. So now we have 1 over 5 to the -2. That kind of looks like what we had here, so 1 over 5 to the -2. So we can rewrite this. The 5 now goes in the numerator, because it was in the denominator before with a negative exponent. And now when we make that change, it'll now be a positive exponent, so positive 2. So 5 to the power of 2 is 5 times 5, and that's easy. That's going to be 25. Let's look at a couple of more examples. So in this next one, we have -3 to the power of -3. And here's something I want to tell you right now. A lot of students get confused with this negative out front and this negative in the exponent. These have nothing to do with one another. They are completely separate. This one makes this number a -3, and this negative makes this exponent a negative, and we're going to deal with it like we were in those previous examples. So I can rewrite this, since we have a negative exponent, and this -3 here is in the numerator. I'm going to rewrite it and put it in the denominator. So I'm going to have -3, and notice I'm going to keep these parentheses. And now I'm going to have to the positive 3, because that's how we can change our negative exponent to a positive exponent, by taking the reciprocal. And now I can say this is going to be -3 times -3 times -3, and all that's in our denominator. So a -3 times a -3 is a positive 9, and then a positive 9 times a -3 is going to be a -27. And the only thing I don't like about this at this point is I don't like to have this negative in the denominator, so I can either put it on top or I can put it out front, either way, but we just don't like to have negatives in the denominator. So when I rewrite this, I get -1/27. Okay, let's go down to the next example. We have -6 to the power of -2. So similar to that previous example, I'm going to put 1 over and this -6 to the positive 2. And notice again I keep these parentheses. So I can rewrite this as 1 over -6 times -6. And -6 times -6 is going to be positive 36. So I have 1 over 36. Let's look at a few more examples, but this time we're going to use variables instead of actual values. So in this first one we have x to the power of -5. So we're going to deal with that just like we were before. So this x will become 1 over x, and this -5 will become a positive 5 exponent. So we can rewrite this as 1 over x to the 5th. Okay, this next one is 1 over y to the -3rd power. And again, because this negative exponent, we're going to take this y from the denominator, and we're going to put him up there in the numerator, and we're going to change that -3 exponent to a positive 3 exponent. So that example becomes y cubed. Okay, so let's jump to the next one. 3a to the power of negative 6. Okay, we've got to be careful here because a lot of students get confused as to what all gets affected by this negative 6 exponent. Well, there's no parentheses here, so the only thing that's going to be affected by this is the a, because that's the base. This 3 is just being multiplied by this a to the power of negative 6, so the 3 is not going to be affected by this. So the 3 stays in the numerator, just like that, where he was, and this a to the power of negative 6 will drop to the denominator and become a to the power of positive 6. Notice only the a got shifted around and the 3 stayed where he was. Okay, similarly, in this next example, we have negative 2 over d to the power of negative 3. So only the d is being affected by this negative exponent, so only the d will move. So this negative 2, which is in the numerator, stays in the numerator, and this d that has the power of negative 3 will go up to the numerator and change to a positive 3 exponent. So we have negative 2d cubed. Let's just look at a few more examples here. So we've got another one that is x to the power of negative 4, and that's in the numerator. In the denominator we have y to the power of negative 5. So it looks like we've got a few different negative exponents to deal with here. We've got a couple of them. So this x to the negative 4th that's on top will transition to the bottom and become x to the positive 4th, while this y to the negative 5th that's on bottom will move up to the top and become y to the positive 5th. So really we take the reciprocal of both of these, and what happens is it just flip around. So the x to the negative 4th goes on bottom to become x to the positive 4th. The y to the negative 5th on bottom jumps up to become y to the positive 5th on top. Okay, in this example we have 2a cubed over b to the power of negative 2. So in order to simplify that, I've got to deal with this negative exponent, and the 2a cubed is fine just where he is. But this b to the negative 2 that's in the denominator will jump up to the numerator and join this 2a cubed, and the exponent will become a positive 2 instead of a negative 2. So we have 2a cubed b squared. In this final example, we have m to the power of negative 4 over n cubed. So, and again, this n cubed here is fine just where he is, so we don't need to worry about moving him. The one we have to deal with, though, is m to the power of negative 4, and since it's a negative exponent and he's in the numerator, we're going to move him to the denominator and making a positive exponent. And like we said, the n cubed was just fine right where he is. Well, you'll see that once this m to the negative 4th got moved, there was nothing left in the numerator. So what does that numerator become? And you have to be really careful with this. This numerator is going to become a 1. Don't say 0 or don't say any other value. When there's nothing left up here and everything gets moved away, you do have a 1. Just like whenever you're simplifying fractions and everything reduces or cancels out, you're left with a 1. So this is how we deal with negative exponents.